Good evening, everyone. Welcome. Thank you all for joining us this evening. We certainly appreciate you coming out on this lovely spring northern Michigan evening. It's sunny out. It's not too hot. I feel like we should all be outside, but we're inside instead to learn about why it's sunny and not too hot, as opposed to too sunny and too hot, which we've had a couple of days, right? Already this year. So thank you for coming. My name is Melissa McKenna, and I'm the department head for adult services here at the Woodmere Library location. So if you have any suggestions for books or programs or other events and services you'd like to see offered here for adults, please let me know. Right. So it is my pleasure to introduce this evening Chris Edwards. Chris Edwards began his career as a forecaster in the U.S. Air Force. He was one of the first meteorologists with the Weather Channel in Atlanta before moving on to forecast in Milwaukee and Philadelphia. He was the chief meteorologist at WJBK TV Fox 2 News in Detroit before leaving to start his own business teaching weather science. He began carefully studying and reporting on global warming in 1987, back when that's what it was called, right? Chris has been honored with 3 Emmy Awards for environmental reporting and weathercasting, as well as recognition from the Michigan chapter of National Association of Television Arts and Scientists for Best Weathercast in 1999, 2001, 2002, 2003, and 2004. You had a stretch there, right? As a retired TV meteorologist, he now enjoys part-time work teaching communication skills at the University of Michigan, where he collaborated with Professor Richard Rood to produce a video on climate change. Chris also serves as the climate change specialist for the city of Detroit and regularly gives climate change presentations just like this to a variety of organizations. So thank you for being with us today, Chris.
Thank you, Melissa. Thank you. Thank you. I appreciate that. I appreciate you all being here. As Melissa mentioned, obviously it's beautiful outside. There are probably other things that you could be doing. I appreciate the fact that you're here. We are going to talk about the changing climate. I really wish that, since I love Northern Michigan so much, my wife and I were married just down the road in Leelanau County on the beach almost 30 years ago, and we've been coming up here ever since, and she was coming up before that. I love this area. I wish that we could sit around, all of us, and talk about tips for hunting morel mushrooms or something like that. That would be so much more fun. But what I do promise you this evening, no tips in that regard. I'm clueless there. But what I'm late. I'm clueless and late. Yes. But what we are going to talk about is something that obviously is critically important. I think most everybody in this room probably recognizes that. But when we talk about our changing climate, I want you to understand right off the bat that we are talking about simple, serious, and solvable. And right at the onset, I want to make sure that we focus on that third word, because sometimes we can get exasperated and we can feel a sense of hopelessness that perhaps maybe it's too late. I'm going to tell you right in the first 2 minutes that that is not what this is about, because I and we, meaning the meteorological climate science community, believe that there is still time for solving. And we're going to talk about that, but we're going to talk about these things in order: the simple, the serious, and the solvable. So I'll back up just a moment, and I want to give credit where it's due. This presentation this evening is climate science, and it is one of the biggest challenges we face, clearly, but I am taking advantage of the marvelous work that the folks at Climate Central do, the bottom right corner there. It is, in case you're not familiar with them, they're a policy-neutral news organization that analyzes and reports on climate science. I've been working with their meteorologists actually since they started in 2008. And this is a presentation of facts derived from scientific consensus. And where I diverge from that toward the end, I will let you know and make it very clear. Very briefly, those that were seated a little earlier will have a little better idea of this. This is this morning's satellite picture. And this morning, you might have noticed that the sky looked a little different. There was a lot of wildfire smoke in the sky. That was from northern Alberta fires that have come in the wake of record-breaking heat for May in northern Alberta, which is more likely because of climate change. It's not directly attributable to any single event. But if you wonder, are there concrete, discernible things that we're seeing from climate change in our area? Almost every day, if you know where and how to look, we are seeing things like that. So back to the simple, serious, and solvable, because That is also an outline for what we're going to discuss. Simple meaning we understand the problem. Serious meaning it is already impacting us and the impacts are accelerating. And solvable, as I mentioned, we have the knowledge and tools to avoid the worst impacts. And I'm going to go over those in order, one at a time, as we move through the evenings. Let's start with simple, which I think is a really nice, for me anyway, it's a great place to start, because simple in this case means the basic idea of climate change is that humans are burning fossil fuels. And I mean coal, oil, and natural gas. Been doing that for a long time. The burning puts carbon dioxide, CO2, I'm going to use those terms interchangeably, CO2 into the atmosphere. And for those of you for whom this is a review of things you know very well, bear with us, it won't take very long. We'll use this as a building block because CO2 is a greenhouse gas and it makes the planet warmer. Now, let's talk a little bit about the atmosphere that surrounds us. 99% of the atmosphere are made up of two gases, nitrogen and oxygen. But there are very important trace gases, which together make up about 1%. Those four trace gases are water vapor, carbon dioxide, methane, and nitrous oxide. These gases are important because they are greenhouse gases, meaning they trap heat. And we'll go into a little bit more detail on that in just a bit. We're going to focus mostly on carbon dioxide, to a slightly lesser degree on methane. And for the most part, we're going to leave water vapor and nitrous oxide aside because time is limited and they are not nearly as important. By the way, forgive me, I should have said this at the onset. I'm going to move through these slides relatively quickly. But at the end, that just gives us lots of time for questions and answers. So when you have a question, do please hang on to it. I'll just tell you right now, it's my favorite part of the program, is when you ask questions, because I'm going over as much as I can in roughly an hour, but I might not cover what it is that your questions are. So at that time, I will take your questions. I will try to provide the answers. Because I know that I'm not going to cover every single thing that has come to your mind, either before this evening or during the course of the presentation. All right, so having said that, those two gases, for our purposes tonight, carbon dioxide and methane, are where we're going to focus a lot of our attention. But first, let's back up a little bit. And for some of this takes us back to perhaps high school science, earth science class, something to that nature, the greenhouse effect. Some people, if you go back far enough, and I wasn't yet out of college, but in the 70s, I was interested in weather already. And there was a lot of talk about the greenhouse effect and kind of used interchangeably with global warming. They call it the greenhouse effect. Well, they're very, very different. The greenhouse effect is vital, been around for millions of years, and it's a good thing we have it. Here's how it works. Sunlight reaches the earth from a long, long way away. Now, some of that energy is reflected back into space, of course. A rather significant amount of it goes back into space. But some of that energy is then absorbed and re-radiated around the globe as heat. That is part of what the greenhouse effect is. And it's those gases in the atmosphere that allow it to do that. Most of the energy is absorbed by greenhouse gases and then reflected in all directions. And that warms the earth significantly more than we would have if they weren't there. If we did not have the greenhouse effect, the average temperature of the earth would be about 0 degrees Fahrenheit, whereas now it's about 60 degrees Fahrenheit, though of course that number is rising. But it really is the difference between a livable planet and one that would provide us with tremendous amounts of challenges. Slight changes, though, in those greenhouse gas concentrations can alter the climate, and it affects the entire world. And that, at the core, is kind of what we're talking about. Now, how far does the science go back? A long way. Starting back in the 1820s, even if we didn't even start to learn about this at all in our minds or our societies until perhaps the 1900s. In the 1820s, Joseph Fourier in France proposed that there were gases in the atmosphere that were keeping Earth warmer than it would be without them. 200 years ago, he did that. And in the 1850s in this country, Eunice Foote discovered that carbon dioxide actually warmed the air around it, around us. And let's just very briefly hear it for a woman in science in the 1850s who made progress like that. Women in science, yes, give it up for women in science that do incredible things and have been for a long time. And without going backward too much, she didn't get credit for that work until just about 20 years ago. For over 100 years, a man who did the same thing 3 years later got all the credit. Right, in the 1890s, Svante Arrhenius from Sweden really kind of took things quite a step farther. He calculated that a doubling of the atmospheric carbon dioxide would raise the Earth's temperature several degrees. The 1890s, 130 years ago, he did that. And in the 1930s, Guy Stewart Callendar from Great Britain, he refined Arrhenius's calculations. He made the first climate projections way before we had computers, and he assembled the evidence for global warming. And his work is so important that in the climate science community, many people call it the Callendar effect, rather than anything that you might have heard in the mass media. All right, so that's a little bit about the history of the science. So carbon dioxide plays a critical role in regulating the temperature of the planet. We've known that a long time. But in the 1800s, particularly the middle part of the 1800s, we started burning a lot more fossil fuels, first coal, and then oil and natural gas. Now, these fuels powered the Industrial Revolution. They raised the standard of living of millions of people all over the world, but they also increased the amount of CO2 in the atmosphere. So if Callendar and the others are correct from what they were proposing, then we would expect to see temperatures rise as the CO2 rises. So let's look at the data. This is a plot of CO2 or carbon dioxide in the atmosphere going back to the late 1800s when our baseline was right around 290 parts per million, roughly. And you can see it went up in a fairly steady slope into the mid part of the 1900s. And then really started to make a pretty quick vault. A lot of scientists call the period after 1970 the Great Acceleration, when a lot of things started to change in a significant way around 1970, which is within the lifespan of some people in this room. Well, where we are now in terms of CO2, we're up around 415. It varies a little bit time of year, but we're up around 415 parts per million now, or about 50% higher than what we were before the Industrial Revolution. So if they were correct, as the CO2 rises, the temperature rises. And what have we seen? This is the temperature plot over the CO2. Now, are they exactly the same all the time? Of course not. There are some divergences, but the trend is extremely clear. And as the carbon dioxide has continued to go up, the average temperature of the world has continued to go up. We'll talk about things other than averages in a moment. But I do want to, for just a moment, take us back a little farther than 140 years. How about 800,000 years? When we look at this is carbon dioxide over about the last 800,000 years. And you see, for most of that time, we hovered between about 180 and maybe 300. There's a 300, 400,000 years ago, right around there, okay? So for all that period of time, because people will sometimes say very correctly that the climate has always changed. It absolutely has always changed. And part of the reason that it has always changed is because carbon dioxide levels have always changed. The big difference, well, there are two. One big difference is that we have not been anywhere near this level of carbon dioxide in at least 2 million years, and maybe longer. And certainly humans weren't too evolved as a civilization at that point. But not only are we much higher than we've been in any time of even remotely recorded history, but we got there so much quicker. This is essentially a geologic or semi-geologic time frame, and we have rocketed up there in a very short period of time. And in that sense, this is not at all like any kind of climate change that we have seen. I might add that the third difference is that this is produced by humans rather than natural forces. All right. A brief moment about methane, because methane is getting more and more attention now. In the 36 years that I've been studying climate change, methane certainly is getting more attention now. We're understanding its impact to a greater degree. And we will discuss this somewhat a little later, but back into the early 80s, the methane levels were below 1650. Now they're averaging over 1900. This is the concentration in the atmosphere overall. Now, why is methane important? Well, for molecule, methane is about 10 times more potent. Excuse me, 80 times more potent, my mistake. 80 times more potent molecule by molecule than CO2 is. So obviously, it's much bigger a deal molecule by molecule. But the good news about methane is that it doesn't last as long in the atmosphere, and that's huge. Methane breaks down in 10 to 12 years. CO2 takes upwards of 200 years to break down. So I'm getting a little ahead of myself, but when we start to talk about solutions and things that we can do, methane is the low-hanging fruit, because if we can knock it down, then 10 to 12 years, it won't be there anymore. As much as we might knock down CO2, it's still going to be there unless we physically pull it out of the atmosphere. even in 100 years from now, but not so with methane. And that's part of the reason why methane is getting more and more attention in the last few years, well-deserved attention. All right, let's bring it home. How about Traverse City and how things have changed much longer than the lifespan of those of us in this room, I'm happy to say. But it's pretty clear, because when you talk about global averages, that's nice, but how about around here? Well, you can see these are 30-year, each bar is 30 years, because climate is a rolling average of the last 30 years, so that no one year or even a couple of years can have too large an impact, the way climatologists look at these things. So you see the first 30 years of the 1900s, it was below the overall average of the 20th century. But it does not take a statistician to recognize the trend here, nor the fact that on average over the last 30 years, we're 2.5 degrees Fahrenheit. Unfortunately, we're going to bounce a little between Fahrenheit and Celsius, but I'll try to keep it clear. We're 2.5 degrees Fahrenheit warmer here in this area than we were on average in the 1900s. That's part of what's going on, because temperature drives a lot of other things that we'll talk about. Look at the same thing a little bit differently, and in this case, exclusively within at least the lifespan of most of us. In the 70s, we averaged here just under 45 degrees, and that's all year, average the highs and lows for all days of the year. Just to give you a little bit of an idea how in our backyards here in Traverse City, how things have changed. So we've gone from the 70s to the 80s, a modest range, a pretty significant rise then in the 90s. This, by the way, was driven in part by a sequence of El Nino events in the 1990s, which we came to understand better starting in the 80s. And by the way, we're setting ourselves up for a strong El Nino year in the next 12 months. So we need to be prepared for that. That's going to mean warmer temperatures worldwide and most likely here in northern Michigan as well. So there were a lot of those in the 90s, and then a slightly smaller number of those in the aughts. So we essentially stayed static, and then a pretty nice big jump again in the 2010. So where are we? We're about 2.5 degrees warmer on average just since the 70s here in the local area. And another thing I think a lot of people find interesting, what season here, and this is all of Michigan. This is not just Traverse City, but this is averaged out over all of Michigan. What we're looking at here, this blue line is winter. In the essentially 50 years since 1970, how much has each season warmed? And winter has warmed the most. The biggest change in our seasons has been winter. It has warmed. Not far behind it is fall in the orange line. And noticeably lower, but still with a clear trend, both spring and summer have risen rather modestly since then. And again, you can look at cities all over Michigan, in the UP, lower Michigan, they have a very similar sort of thing. The winters have warmed more. In other parts of the country, and certainly in other parts of the continent, there are different manifestations. But here in our part of the world, winter has warmed the most, the fastest, and we're continuing to see that. All right, so we know CO2 affects temperatures. We can use that knowledge to look into the future, because as interesting as history is, it's as an insight into what's going to happen that has the most value. And climate scientists use sophisticated computers to predict how Earth is going to respond to rising CO2 levels. Now, the earlier versions of those computers that we started looking at in the 80s predicted the warming that we are experiencing now. Just for the record, it wasn't quite fast enough predicting the warming we have, but the 80s models did a pretty darn good job. Now, these models that were much more sophisticated now are telling us two things. Number one, the amount of warming depends on future carbon emissions. And number two, if we reduce the emissions, temperatures will stabilize. The longer we wait, the worse it gets. That's basic science as well. This is the path we're on. And unfortunately, these are Fahrenheit temperatures by the end of the century where we would go. On the flip side, if we make significant emissions cuts, we're more in this area. Notice, and when I talked about solvable, I did not say anything like easy. We're still going to rise no matter what we do. But how fast we rise and for how long we rise at that kind of a rate depends on future actions. More on that in a moment. All right, so enough of the serious. What does it mean? What are the consequences? Well, when we talk about climate change, whether you want to call it climate change or global warming, one of the reasons we call it climate change is because it impacts more than just warming, because the warming temperatures lead to wilder weather and rising seas, and some specifics about that are what we'll talk about. it's important, first of all, to recognize, and we're back to the bell curve that we also might either fondly remember or despise from our school years. The bell curve shows us here plainly that when we move the averages over, it isn't just the averages that move, but it makes the significant heat and the extreme heat much more likely and prevalent. On the flip side, it makes the extreme cold and the significant cold much less likely and less prevalent. Doesn't mean it doesn't happen. Extreme cold still happens. As a matter of fact, Richard Root at U of M was one of the scientists that has done some very significant work showing that the disruptions in the upper levels of the atmosphere break off more cold air from polar regions than what we used to have. So as counterintuitive as that may seem, it's actually true that we can get blasts of very cold air more frequently sometimes than we used to, but huge difference, it doesn't last as long as it used to. And overall, that's only for some parts of the year. Overall, these things worldwide are becoming more common as you shift the averages from left to right. By the way, back to averages, globally, the warmest 8 years on record have been the last 8 years. Globally, the warmest 8 years have been the last 8 years since 2014. But as I mentioned, it isn't just temperature we're talking about. What does it bring to our weather? I talk about wilder weather. Well, we in the meteorological community have what we really smartly call billion-dollar disasters. I don't know who was creative enough to come with that, but as the name implies, these are weather disasters which cause at least $1 billion in damage. And for many, many years, we averaged about 7 of those per year. And by the way, these are inflation-adjusted dollars. We averaged about 7 of those. Then lo and behold, and again, this is just in this country. There are similar trends in other parts of the world, but we have the data for here. In 2011, we just had a wild year where we had 16 of those $1 billion or more disasters. Then things settled down a little bit, but then in 2017, we did it again. We had 16 of them. And by the way, these are things like severe weather outbreaks, hurricanes, huge floods, nasty ice storms, things like that. In 2017, we had 16 of them again. Then in 2020, we had 22 of them. Now, we were a little distracted with a pandemic in 2020. You're forgiven if you don't remember that. But in 2020, 22 of them, we'd never had that many before. 7 of them were linked to landfalling hurricanes. The very next year, we had 20 of them, including 2 historic severe weather events in the Ohio Valley. In December, we had tornadoes that not only caused billions of dollars of damage, but took multiple dozens of lives in December. We in the weather community did not think that could happen, but it did in 2021. And then it's not graphed here yet, but in 2022, the year just that we just finished, we had $18 billion disasters. So we're going to put ourselves right up in here, including one, Hurricane Ian. All by itself, Hurricane Ian produced $113 billion in damage. So when we talk about the fact that there will be cost to making changes and mitigation, we also have to recognize that there is cost to lack of action in dollars and cents, without even talking about humans, of course. And this is a trend which we expect to continue as well. Very briefly, side note, obviously, as you have more development, like in Florida, you are going to increase the dollar loss. So this is not just a function of intensity of storms. It is a function of development and infrastructure and human choices that have been made, but they are related and they work together to cause these changes. And speaking of changes, a little bit about how snowfall patterns change as we warm the atmosphere. Now, milder climates get less snow as temperatures are more frequently above freezing. Late fall and early spring snow is actually on the decline in many localities because that precipitation tends to more likely fall as rain. Cold climates, like ours, of course, can actually get more snow. Very briefly, I will say, when here, as we're here in Traverse City, we get lake effect snow here. When the lakes stay warmer longer, and when they stay open and free of ice, they are a fuel for lake effect snow. So when somebody looks out and sees a lake effect snow squall going through and looks at somebody and says, yeah, so much for global warming, that is exactly what we would expect in global warming climate change, is that we would have more events like that because you have warmer waters and you have more open waters, and the lake effect snow squall season can be more intense and it lasts longer. So they are not proof that climate change is not happening. They are the opposite of that if you want to look at a single weather event. And by the way, in a lot of mountain locations, more of the winter precipitation is falling as rain. That's a problem because they count on the snowpack to feed their not only their aquifers, but their reservoirs for the entire warm season. So that's an issue for them. A little less so here. All right. These sorts of pictures seem to get a lot of play, and I'm going to show this one representative picture of glacier in just 7 years, glacier retreat. This is up in the Kenai Fjords National Park in Alaska. This is the Bear Glacier, and in 7 years, you see how it has retreated. Now, melting glaciers and ice sheets are all over the world, but the poles, north and south, are warming 4 times faster than mid-latitudes. So these areas are experiencing this kind of dramatic change faster than anywhere else. The people that live in those areas are experiencing massive disruption to their ways of life 4 times faster than us. So if we want to have a look at what our future is, particularly if we don't make the changes that we want to make to our future, we look to their lifestyles and their way of living for a very long period of time, which has been greatly disrupted. Unfortunately, glacier loss also means that people that rely on glaciers for their water might not have it in the not too distant future. And this is not only going on at the poles, it's going on in the high mountain regions all over the world, the Alps, the Western United States mountains, the Andes, the mountains of course, the Himalayas. They're all seeing similar glacier retreat, much, much faster, not only than we've seen before, but again, I'm going to tap into me studying this since the 80s, faster than we expected it to happen. The glaciers are melting more quickly than they were projected to melt. Because I remember back in the 80s, people would say, well, it might not be as bad as you guys say. It also could be worse. And that's the thing about averages, and that's the thing about most likely scenarios. But I digress. Let's talk a little bit about the oceans. Now, this map, a little deciphering, there's a lot going on here. I will acknowledge that. The black are land masses. This is the ocean water temperature. And wherever you see this orange or yellow or red, this is where ocean water temperatures have warmed. Now, this area is not a big area that's cooler. This is a data void. We don't have data down here. This has something to do in part with map projections and things like that. But let's disregard this. So absent that color, and you see all this red and orange, does anybody see anything that kind of jumps out as something a little bit different in these temperature trends over the last 120 years? Because this goes back to 1901, I think this data set. Give you a moment to look at that while I take a sip of water. Anything stand out that's a little bit different from the rest? Greenland. Thank you, whoever said that. Right there. I remember when I first saw this map years ago, excuse me, I said, what is that? What is going on there? Is that a data problem? Okay, I'm asking. Anybody have any clues? What's going on there? That's it. The continent of Greenland is covered mostly, less than it was, but it's mostly covered by glaciers. Those glaciers are melting quickly, and they're pouring enormous volumes of cold, non-salt water into the North Atlantic, right there. Year after year after year, we're seeing this cold patch of water here compared to what it used to be. Now, you might think, well, maybe that bothers some fish, but what does the rest of it matter? It matters because ocean currents, and ocean in general, but ocean currents particularly, this being the Gulf Stream, which runs up the eastern part of North America and then goes in this direction and starts working south off the west coast of Europe, it drives weather patterns. And when you do that to the oceans, you screw the weather patterns up enormously. Now, what does that mean for weather patterns? We don't know. There are theories, but we don't know. I promised you at the start I was going to talk about facts. The fact is, we don't know what that's going to mean, but it's showing up year after year after year. It's accelerating, and we are conducting a rather large experiment with the globe with this. And scientists, of course, they throw an acronym on something that's called the AMOC, or the Atlantic Meridional Oceanic Circulation. You don't need to remember that. What you do need to remember is that particularly people in Western Europe are extremely concerned because this is where their weather comes from. It comes from here. Now, on a broader level, as the graphic says, over 90% of the extra heat that we've put into the atmosphere over the last 150 years has been absorbed by the oceans. And that's great because it's minimized, well, it's nice in the sense that it has minimized the impact on land masses where we live. But the oceans are a little bit like a sponge. A sponge, even a big thirsty one, can only hold so much before it's dripping out and it can't hold anymore. The oceanographers are telling us that the oceans are getting really close to the point where they're saying that's about it. And then more of the transfer of heat is going to be felt on land and less on water. I mean, it's pretty important. Oceans are over 70% of the Earth's surface. They've been doing a lot of work to deal with the changes that have been injected into the atmosphere. But there is a limit to what they can do. So sea level rise then, this is over the last 2,000 years. Each bar represents 100 years. And what we've seen over the last 2,000 years is for 100 years, the sea level goes up a little, it goes down a little, a couple inches, an inch and a half. Whoop, 1900s, it went up almost 6 inches. We've never seen anything like that in over 2,000 years. Now, some people will say 6 inches of sea level rise, so what's the big deal? Well, it makes a huge difference, particularly to the tens or hundreds of millions of people that live within 25 feet of sea level around the world. And we're now a fifth of the way into the new century, and the rate that we're rising now is even higher than the rate we saw in the 1900s. So that, of course, leads to more flooding. And even though we don't live near the ocean, we certainly understand the importance of flooding. This is over the last 15 years and the number of days of flooding in coastal areas in this country. The slope is pretty clear. By the way, in Florida, they have what they euphemistically call their sunny day floods. Sunny day flooding at high tide, because they don't even need a storm to get flooding because the sea levels have risen. If the wind is just persistent out of a similar direction, it will produce flooding. And I'm going to divert from the slides for just a moment to talk about the Great Lakes. Obviously, we have a lot of interest in Lake Michigan and the surrounding basins here. This is one of the more interesting areas of what the computer models have shown. Up until about 10 years ago, most of the computer models were hinting that the overall level of the Great Lakes would rise in a climate change world. It would be tending toward rise. The computer models have gotten more sophisticated. There are a lot of variables involved. And they are now saying, and have been doing so for about 10 years, so they're kind of locking in on this. They are saying that rather than an overall rise, we're just likely to see more of this. Up and down, faster than we've seen before. Up and down, up and down, up and down, because we have competing forces. We'll get to this in a moment. Warmer atmosphere holds more moisture. You can get heavier rains in certain areas. That leans toward up. On the other hand, warmer temperatures, ice-free lakes lead to more evaporation, and so that plays the other side. So the models are finally latching on to what we can expect in the Great Lakes is variability on a level and intensity that we really haven't seen over the last couple hundred years since we've put a lot of people into the Great Lakes Basin. So that is what is likely, and that is obviously a significant challenge to anybody living on or near the Great Lakes, or anybody keeping a boat on or near the Great Lakes. And interesting, over the last 2.5 years, after the lake levels went way up in 2020, they have fallen faster than they've ever fallen in clearly recorded history. They certainly might have a long time ago, but they've fallen very, very quickly in the last 2.5 years. Okay, important point here about warmer air. I alluded to this before. The difference between temperature and the amount of water vapor in the air. And this is probably the biggest area when we talk about climate change. It isn't just warming. When you warm the atmosphere can hold more water. Hugely important, makes a massive difference, and we're seeing those differences. A warmer atmosphere holds more water vapor. Think about the summertime. It's humid in the summer. You feel the stickiness of the summer because the air is warmer. It can hold more moisture. That's why you get uncomfortable. An increase in temperature allows more evaporation into the atmosphere from oceans and lakes and soils and plants, so more available water is there for storms. And remember, As I said before, 70% of the globe is water. So this effectively supercharges the water cycle, increasing the rain and snow in heavy precipitation events. But it also can lead to larger, longer droughts, because even though the atmosphere can hold more water, if the water isn't there, then all it does is heat things up more and allow a drought to get worse and allow a flooding situation to get worse. And that's counterintuitive. But what climate change theory is telling us is that the wet areas get wetter and wet seasons get wetter, the dry areas get drier. There is increased potential for extremes in both directions. And that, I recall, goes back to the models of the 80s. That was expected to be seen. It wasn't really being seen. Now it is being seen. These are differences in heavy precipitation events by different region of the country. And you can see in our part of the country, 42% more heavy downpours than what we had prior to this data set. This data set goes back to the late 50s, I think. Yeah, 58. And the Northeast, it's actually greater than that. And it's a little less in the Southeast and less still in the West. Everybody is seeing more heavy downpours, but our part of the country in the Northeast seeing more of them. And unfortunately, again, all you have to do is pay attention to the news. Last summer in Kentucky, flooding took dozens of lives. In eastern Kentucky, in the St. Louis metro area, they had over 8 inches of rain in less than 10 hours. And what happened last month in Fort Lauderdale? I don't know if any of you heard about 26 inches of rain in 7 hours in Fort Lauderdale. 26 inches of rain in 7 hours, even in Florida. That is an unheard of amount of rain. So it is impacting lots of places, and we are trying to deal with an infrastructure that cannot deal with those kinds of precipitation rates coming in these big events, big rainfall events. More intense rainfall. This is actually for Metro Detroit, but the slope is the same. When it rains, it tends to rain more heavily. Now, I know we here in northern Michigan are dealing with a brief, significant dry spell, unusual stretch of dry weather. But when rain does return, it has a greater likelihood of being heavy than what it did in the past. Now, I'm just going to spend a couple of brief moments on hurricanes, because one of the many reasons we love Michigan is that we don't get hurricanes. And even in a climate change world, we won't get hurricanes because it requires things that we do not have here. Hurricanes do. But when Ian made landfall in late September in Southwest Florida, I heard a lot of talking heads on different media that were saying something very similar to this. Well, with climate change, we can expect to see more hurricanes. That is not what the science shows. And I'll make it really clear. That is not what the science shows. The latest science is actually showing that with climate change, we will probably see a similar number of hurricanes, or maybe even a slightly smaller number, because of a lot of complex things that go on when a hurricane forms. But unfortunately, that's the end of the really good news in this regard, because even though we will see the same or possibly fewer hurricanes, we will more likely see stronger hurricanes of the ones that do form, that carry more rain, because what I talked about just a moment ago, that bring heavier rain and a higher storm surge because of the increased sea levels. So when you start out from a baseline that's lower, you're going to do more damage. Some very interesting research in the last 3 to 4 years is showing also that the hurricanes making landfall in the United States are tending to do two really nasty little things. They slow down right before landfall, and they increase quickly right before landfall. Now, that is a nightmare for emergency preparedness people when a hurricane changes quickly. And the fact that it slows down, I mean, just think about your crazy uncle that comes to visit. Do you want him to move through at 10 miles an hour or 40 miles an hour? Get in and get out. Unfortunately, the hurricanes are tending to slow down, and the research is pointing to a likelihood that that may continue in terms of changes with hurricanes. So I want to make it clear what the science shows and what it doesn't show. For those of you who know people in Florida, have interests there, perhaps visit there frequently, or anywhere else along the Gulf Coast or the East Coast for that matter, because a whole lot of parts of this country are susceptible to hurricanes. On the flip side of the coin, and particularly here, we're looking in the Western US, I'll be brief with this one, but basically the longer and more frequently you see these bars, it's more intense a drought is. We're going back to 1900. We're seeing more intense droughts that last longer, going more into the extreme. As a matter of fact, before this winter, the Western US, I'm talking particularly about the Great Basin, California, surrounding areas, were in their worst, most persistent drought in 1,200 years. Now, this winter has knocked that drought way down. It's knocked it kind of loopy. But that also is a very interesting mark of what we expect to see in climate change, and that is more extremes. So we've gone from the worst drought in 1,200 years to the Sierra Nevada getting at least the second highest snowpack since they started keeping track in the late 1800s. They have enormous amounts of snow in the mountains out there right now, perhaps more than they're going to be able to handle as the melt continues. Back and forth, the extremes, like I was talking about with the Great Lakes, they get seen with precipitation as well. However, overall, there's a lot of reason to be concerned that droughts in the Western US will be more persistent and deeper and more significant as they occur. So we've talked about the wild weather, but there are other aspects of climate change that affect people, nature, our health, the economy. Let's talk a little bit about that because, of course, we humans are not the only species, as we need to sometimes remind ourselves. We're seeing climate change impact almost the entire natural world, as you might expect. You see animals and plants, they're adapted to specific climate conditions. And again, although we have seen climate change before, we have never seen it this rapid or even close, nor have the other species that inhabit the planet. So as the climate warms, many of these species are trying to move either northward or toward the poles or to higher elevations. But some of them can do that and some of them can't. You get seasonal cycles that get disrupted with, for instance, plants that bloom earlier in the spring, and the things that feed off those plants might not be there yet. These mismatches between predators and prey can be pretty significant. And then some ecosystems, like in the ocean, in the coral reefs, the warming of the oceans have done a tremendous disservice to the coral reefs all over the world. Very sensitive to temperatures, severely impacted by heat waves in the ocean. We might not think about it much, but we get severe heat waves in the ocean sometimes. And that has an impact on those ecosystems very deep in the ocean. Now, back to humans and talking about health. Overall, there are far more negative implications to climate change in our health than there are positive. Some of you may be happy that you don't have to wear as many layers in a January day, and I totally understand that. But we have to recognize that overall, the negative impacts are significant. To name just a few, air pollution is worse as a result of climate change. It amplifies some sources of air pollution like wildfires, as I talked about before. The burning of coal and diesel, also those are CO2 sources which get directly into the atmosphere. Now, heat impacts us directly, increasing days, for instance, where physical activity is either unpleasant or unsafe. And perhaps that doesn't happen all that much in northern Michigan, but in many, many parts of the world, it's happening more than it used to and earlier than it used to, by the way. Already Southeast Asia has seen Laos, Vietnam, and Cambodia have all seen their warmest temperatures ever recorded in the last month. And in those areas, we're talking about temperatures that make it very difficult to even go outside when they're the warmest they've ever been recorded. It impacts anybody that goes outside, people that work outside, athletes, people that like to take walks. Mosquito and tick-borne diseases. I just read a study yesterday about how Lyme disease in Michigan, much longer period of time when we have to be concerned about Lyme disease, and the ticks that carry Lyme disease are more numerous. These are impacts that are continuing to spread into new locations and stick around longer. Longer allergy seasons, hay fever, allergy-induced asthma are a greater concern because of the warming temperatures and the things that are related to it. And high CO2 levels, by the way, even make poison ivy more widespread and even more irritating. Now let's talk about food and farming briefly. It's impacting how we produce food and obviously the people that work on those farms. And agriculture is a huge part of the Michigan economy. And there are impacts, obviously, from wild weather events. Flooding or drought make agriculture extremely challenging to do. But the planting zones are also shifting. I was just reading that the famous Colombian coffee fields, within 50 years, they won't be able to grow coffee in those fields anymore because it's warming too much. And yes, they can go up in the mountains to a certain point, then you run out of land. And that's happening in different parts of the world, again, very quickly. Crop diseases and pests spread and stick around longer. Michigan State is doing a whole lot of work on helping Michigan farmers and agriculture workers make adjustments to these changes. They're working very hard on it, but again, the changes are very, very rapid. And I can assure you, maybe some are in this room, people that work the land are very aware of the changes that are occurring and how they're not like they used to be. This is where I get to take a breath. We get to the solvable part, my favorite part of the slides. And I will tell you right off the bat, first of all, that we're back to Celsius instead of Fahrenheit. I'm sorry about that. We bounce around a little bit. But the really simple part here is it's solvable, but to stay below where we need to stay below, we need to cut emissions quickly and drastically. Show you that with this little graph. If we keep on our present course, by the end of this century, we're up around 4 degrees Celsius of rise from the baseline, which is about 8 degrees Fahrenheit. And let me assure you, if we get to that level, we don't really recognize where we are if we get to that level. Even though it may have taken decades to transform, compared to now, we won't really recognize where we are. On the flip side, if we make the cuts, we can be in this area. Now, some of you may have heard the IPCC, or essentially the UN has set, as of 2016, the goal of trying to keep it below 1.5 degrees Celsius or 3 degrees Fahrenheit. When we talk about that number, that's the global average temperature, trying to keep it below 1.5 degrees Celsius. Most of the world uses Celsius. That's why you hear that number. You can do a quick conversion and say that's roughly 3 degrees Fahrenheit. Trying to keep it below that. Well, unfortunately, we've already warmed about 2 degrees Fahrenheit. So we don't have a whole lot of room left here. What we need to do, we have to reduce emissions quickly, and we have to figure out some ways to remove carbon dioxide from the atmosphere. So let's talk about it. Let's dive in here, because when you have a problem, before you can fix it, you first need to understand what the parameters are of the problem. Greenhouse gas sources in this country by sector. And you can see 29% of it is transportation. Moving ourselves and our things from one place to another is almost 1/3 of the emissions that we put out in terms of greenhouse gases. Right behind it is electricity generation. It's a huge chunk. Industry accounts for almost 1/4. Commercial and residential buildings, 12%, and agriculture, about 9%. Now, there are other ways that you can divide things, obviously, but these are some of the simplest, and they're important because we have solutions to reduce emissions from each of these sectors. And let's talk a little bit about them one by one. We'll start with renewable energy, sometimes called clean energy. These are the potentials in the lower 48. First of all, on the left, solar energy. And obviously, the darker the shading here, the more solar energy potential there is, the more such energy reaches the surface of the earth. As you might expect, greatest in the deserts of the Southwest. But even in our part of the country, there are significant amounts of solar energy that are seen each and every year, and potential for solar energy increasing. On the flip side of the solar energy is the wind, where you see the darkest blue shadings. That's where the wind blows the strongest and the most frequently. Highest levels in the eastern slope of the Rockies into the western high plains. But again, not insignificant amounts of potential wind energy all over the country. And a quick note about solar and wind energy. In the last 10 years, the overall cost of solar power is down 90% in 10 years. And wind is down about 70%. So if you or people you know have this thought in your mind that it's too expensive, it's too difficult, it's too complicated, the expensive part has largely been knocked out, and the trends are very, very clear. And in many, many cases, alternative energy, or excuse me, renewable energy is actually in many cases cheaper than fossil fuels. So we have to electrify our transport. We know how to produce electricity from renewable sources. People say with good reason, what good is an EV if it's a coal-fired power plant that produces the energy that goes into the EV? It's a great point. We need to start by electrifying our transport. We can use the energy then to move ourselves around. We need to convert cars, buses, trains, other modes of transportation from internal combustion engine to electric, running on clean electricity. And that's an important point. Electric vehicles are getting better and cheaper every year. Battery capacity is growing. There are more places to charge them. We have a little chicken and the egg with EVs. People say, well, I'm not going to buy an EV till there are enough charging stations. And the people that make the charging stations say, I'm not going to put the charging stations up until there are enough cars to use them. That's understandable. It's a challenge. It's a little bit of a speed bump to work through, but we can work through it. It's already being done in many areas. And by the way, EVs are simpler to maintain. And there are some companies that put things out on press releases to try to make people feel better about climate change. And then there are some companies that are making real significant impacts, whatever their motivation might be. I will just say that GM recently committed to making their fleet fully electric by 2035 model year. And they have committed to being carbon neutral as a company by 2040. Ford is on a similar sort of path. They are redesigning their entire business around EVs. And is it going to make a difference? Yes, it is going to make a difference. As we talk a little bit about these solutions, I'm reminded Bill McGibbon is a leader in climate change education. And Bill said that there is no such thing as a silver bullet, and EVs are not a silver bullet. But what we do have available to us is silver buckshot. We have a lot of things that we can do, and let's do them, as many as possible, as soon as possible, if we talk about solvable. So our buildings could be much more energy efficient. We use a lot of energy to heat and cool our buildings. Architecture and building design can increase energy efficiency and require less energy for daily operation. Simple things like improving insulation, save money and energy, increase comfort, do a lot of great things. And quick show of hands, how many of you have heard of electric heat pumps? I have a pretty enlightened audience here, I think. But yeah, okay, so we've got more than half of you who've heard of electric heat pumps. If you haven't, don't worry, you will. Unless you hide in the next couple of years, you will hear about electric heat pumps, which work in this climate to both heat and cool. A lot of people don't recognize that even in this kind of climate, they work. They can work. They are more expensive currently, and rather significantly more expensive as an outlay. But in Western Europe, they're much more widely adopted, and they're adopting them very, very quickly in Western Europe. And we are going to hear a lot more about electric heat pumps heating and cooling our homes in the years ahead. But if you hadn't heard of them before, you heard it here first. We can also reduce the emissions by changing our farming practices and also create better crops. Better agricultural practices lower methane emissions, which I talked about before. That's important. That's a potent greenhouse gas. Also, rice farming and raising sheep and cows produce more methane, and we can do that better, or in some cases do less of that, and therefore reduce the greenhouse emissions from agriculture. Reducing tilling or planting cover crops can keep carbon, water, and important nutrients in the soils. And a lot of parts of the country are experimenting with that and making a transition to doing that kind of tilling as opposed to what they've done traditionally. And composting food waste reduces methane emission over what's done in a landfill and recycles fertilizer right back to crops. Very briefly, too, plants take CO2 out of the atmosphere and convert it right into plant tissue. So productive ecosystems like grasslands and peatlands near the coast, the coastal wetlands, they accumulate carbon in the soil and plants. And if we keep the carbon in the soil and plants, it doesn't get into the atmosphere. That's what we want to do. Clearly, a lot of this land in its different forms all over the country has been lost. But part of what the solvable is to reduce the future loss of this and to reintroduce it where it's possible, because it makes a big difference. And by the way, coastal wetlands also reduce the flooding from landfalling hurricanes and tropical systems. And speaking of trees, in the Traverse City area, the estimate is the trees that are here, such a beautiful city here with its trees in bloom right now, the trees that are in existence here remove 147 million gallons of storm runoff, 8 million pounds of air pollution reduced, and 300,000 tons of carbon pollution by the trees that are here. How about if we plant more of them? There's a great idea. Again, that's not a silver bullet, but it's part of the buckshot. And the old saying that I like is the very best time to plant a tree is 20 years ago. The next best time, today. Okay? Or maybe tomorrow. It's late. Trees make a huge difference. They are not going to solve the problem, but they're something that we can do. And speaking of something that we can do, take a look at those three things that you can figure out what each of them represents. I'll give you some clues. To stay close to 3 degrees Fahrenheit of warming, we are going to need to make big changes, and we're going to make them quickly. I said at the onset that this was solvable. I truly, truly believe that, but it is not going to be easy. It's going to take a tremendous amount. And some people may say, it's too much, we can't do it. But to them, I say, we have made huge changes in the past. This is representing indoor plumbing and electricity that radically changed the life of people in cities. Within a generation, you had the average lifespan go up 10 years. Within a generation, when you got indoor plumbing and electricity in places, a massive change that made cities safer. And people said, we couldn't possibly do that. How about the space age? The space age ushered in technologies that we use to this day. Some of them we carry in our pockets. The space age, when Kennedy said we try to go to the moon not because it's easy, but because it's hard, people laughed at him and said, we cannot do that. And we did. Obviously, we know how that worked out. It was a daunting task. So many people didn't think it could possibly be done, but we did it. And how about the information technology age? 16 years ago, it's not really very long, there were no iPhones. The internet revolution hadn't really even started. And hundreds of millions of people's lives around the world have been changed in just a few decades. So when we talk about making changes in a few decades, we've done it before. We've never done this kind of thing on quite this scale, but we've done some big things before that people didn't think could be done. But reducing emissions is actually a win-win. Creating jobs as it disrupts others, new industries, keeps us safer, limits future expenses from the disasters that I showed you before. I'm going to show two more little graphs for you here. I know there's been a lot of them. And this is for Detroit, but the numbers I checked are quite similar to Traverse City. This is by generation. And when we think about what are we leaving to the next generation, this is by generation how much change in temperature. In this area, this is what's already occurred. This is what future projections are. So the baby boomers, some of us in this room, dealing with about 3 degrees Fahrenheit of change by the end of the generation's life. The Gen Xers are here. Millennials are here. Keep in mind that when we get to this area, many scientists think that life as we currently experience it isn't really even livable. And then these, I don't know about you, but the Gen Alphas, I had to look that one up. Some of them aren't even born yet. They're all 10 years old or younger. Is this what we want to gift them? Is this what we want to hand to them? Because when you talk about climate change with people, I urge you to talk to young people about climate change if you don't. They have a very different perspective, and sometimes they don't feel really good about it. But if we make changes, this is what happens. Still significant for some of the people that are alive today and that we might know well. But look what happens. We have the potential to do that. That's the kind of change that we're talking about. Climate change is simple. The science goes back to the 1800s. It's serious. The impacts are already being felt, and they're just going to continue to accelerate. But we have what we need to make changes. And at this point, I'm drawing a line in the sand and saying we're moving from science to some stuff that's not exactly science. First of all, I want to thank Scott Denning at Colorado State, great guy who helped put some of these slides together and the framing together. But I ask you, when you think about, now, why did you come? Why? I know some of you are in CCL and we'll talk about that, but why do you work to combat climate change? Well, here's my personal reason. This is why I work to combat climate change. And particularly these two, our son and daughter, and their as yet unborn children, and millions like them who haven't done anything for most of their lives to contribute to this. This is why I talk about climate change whenever and however I can, because they are going to get a world that is either going to be unlivable or manageable, depending on what starts happening in the very near future. And with that in mind, this is a slide that I started producing because when we started to get into questions, invariably, one of the first three questions was, what can I do? And this is an arbitrary list of 10 things, which I'm going to leave up here for a couple minutes. I'll go over them very briefly, but I want to give at least a primer in terms of things that can be done, and I will start with the top one. These aren't in any particular order except number one. I firmly believe that the most important thing we can do is to talk to people about climate change, like we're doing tonight, like I do whenever and however I can. Talk to people about climate change. You don't have to use all the fancy graphics and maps and throw all kinds of information with them. Start with the simplest things. What have you done? What have you noticed? How has it impacted you, the things that you've seen change? And does it have to be relatives? No, it can be relatives, it can be friends, it can be strangers, it can be people we meet on the street. I've had so many conversations with people in elevators. Just talk about it. One of the fascinating things I've seen from the research is that more than 2/3 of Americans are at least somewhat concerned about climate change, but less than 1/3 of them ever talk to anybody about it. Okay, we can probably think of a few reasons why that would be, but we need to change that because the person standing next to us in line at the bank or wherever we might be might have as much concern as you, but you never talk about it. And that's the first step to starting to have some kind of an impact, is to talk about it, because then you can begin to have a sort of a group impact, which I know groups like Citizens Climate Lobby do. That is an impact beyond just yourself. But I start with talk to people about climate change. Plant trees. I already talked about that. Fly less or perhaps purchase carbon allowances. There are lots of ways you can do this. I personally am a fan of carbonlighthouse.org and what they do in terms of helping to offset the greenhouse gas emissions from aviation, because we don't yet have economically viable, sustainable aviation fuel, although it's probably coming in the future. We don't have time to wait really for that, but we're pushing it as much as we can. Now, 4, 5, 6, and 8 also have the marvelous bonus of saving money as well. Eat less meat and dairy, try for locally produced food, leave the car at home whenever you can, reduce your own energy use, and cut consumption and waste. Very interesting. When you look at sources, just briefly, when you look at sources of greenhouse gas emissions, you can look at it by country, US or China or whatever, or you can look at it by things that are done. And the amount of greenhouse gas emissions that come from producing and moving food that is wasted would be if it were a country, it would be the 3rd leading producer in the world behind the US and China. Wasted food. So when you cut consumption and waste, it makes a big difference. In the middle there, I don't want to forget number 7. If you're fortunate enough to have money to invest it with climate in mind is something that you can do. Join the local climate groups. Lee, I didn't put in here Citizens Climate Lobby, but you get the idea. Find a group, and CCL is a wonderful group. Actually, one of the things I find is interesting, I know Citizens Climate Lobby has a number of members here, and I'm glad that they were here this evening rather than their normal meeting. Thank you for having your normal meeting before this. Marshall Saunders started that, and Marshall Saunders used to work for Shell. And he started something that is having an impact all over the country with local chapters, including one here in the greater Traverse City area. And those kinds of groups, even if it's not a Citizens Climate Lobby, you can probably find one that matches your skills and interests with what you can do. And then, of course, really important when it's time to vote, we're fortunate to live in a democracy, vote with climate change in mind. A little bit more, first of all, if you have any questions moving forward, you want to know a little bit more about this presentation, know somewhere else that might want to have this presentation, go to weatherchris.com. You can also email me at that spot. And for more great information about what you can do, there's a marvelous series on drawdown.org of 6 different videos. They average 15 minutes about solutions. It's all about solutions. Drawdown.org. Great organization. They do some marvelous communication, which is focused on solutions. My last hour has been spent talking about the entire scope, but solutions are very well drawn up there. So with that being said, I'll be happy to open it up for questions. I'm going to leave this up. If you want to take pictures of it or whatever you want to do, please feel free to do that. I recognize that there are things I didn't get to, as I mentioned at the beginning, but this is your opportunity to ask the questions. I'll try to provide the answers, but I'm going to tell you right off the bat, I may have been studying this for 36 years. I don't know all the answers. And if I don't know, I will tell you, and then I will probably try to find out. So anybody have a question?
Thank you, Chris. I will let everyone know we are recording. So Zoom has been recording the presentation, so it is still recording the question and answer session. So I am going to ask that if you do have a question, please let me give you the mic, because otherwise the people on Zoom can't hear your question. And if we want to keep this in perpetuity on the library's YouTube channel, it's better if we've got all the info for everyone. Okay, so question.
I noticed that 2 or 3 years ago, the water level at Point Betsy, or not Point Betsy, at Lake Betsy by Frankfurt, Alberta, was 3 feet higher than it is now. Has the lakes gone down that much, Lake Michigan?
Roughly, yes.
3
I
feet?
believe the last thing I read was 2.5 feet for the overall basin fall in the last 2.5 years.
Okay, thank you.
Yeah. But keep in mind, this winter, of course, there was very little to no ice cover on Lake Michigan. That leads to more evaporation than you would normally have. And so it allows the lake level to drop more quickly than it would otherwise drop if you iced over. It's a complicated sort of a thing. It certainly is. And that's one of the reasons why the long-term models have had a hard time latching on to what's going to happen to the lake levels. It's a huge question for planners in this part of the world. What are the lake levels going to do? I mean, 20% of the world's fresh water is here. We want to know what they do. We think they are going to do this. And from what I've seen of the climate projections the last couple of years, I think there's pretty good likelihood that that's what we can expect. No big overall rise, no big overall fall, long-term fall, but lots of ups and downs, which are a headache. Anybody else?
One thing I don't see on your list of things that we need to do or should do, I'm thinking that one of the most important things we need to do is focus on educating the future generation much better than we've educated ourselves, because we were stupid enough to fall into this. And if they're the ones that are going to have to fix what we did with our stupidity, they're going to need better education. And I think there needs to be a big move to have free college and things like that, and more science in school. And I think it'd be a good idea to have children in every grade level make a list of 100 things that they find are the most important things and rank them, and do that again next year or next semester continually, and see how they match up with other students as they get older and smarter. Thank you.
Okay. Thank you. I'm not going to disagree with your suggestions. Education is huge. You should know that some states, obviously education is worked both on a state level and a local level, but some states have recently introduced mandatory climate change education into their curriculum. Michigan is not one, but some of the traditionally more progressive states are doing that now. There is a push for more of that. There is a strong push in the other direction in other states. So I think it's safe to say that that's going to be an uneven situation depending on what part of the country you're talking about. There are some parts of the country where they're actively prohibiting that sort of education. And that's the challenge that's faced. But I agree with you that we need to educate the young generation, because this is what we're going to be handing them. They might as well understand early what it is. I agree. And by the way, as we're getting ready for the next question, I suggest that no individual action, as important as all of this is, no individual action is going to do this. It's a three-pronged thing. We need individual action, we need corporate action, and we need governmental action. And one or two of those will not do it. All three. The fortunate thing is that individuals we can impact corporate action and we can impact governmental action. And yes, it needs to be done in other parts of the world too. I'll see if the questions get to that, but that's what we can do in the United States. Please.
Thank you, Chris, for a really great presentation. I just wanted, I'm with Citizens Climate Lobby, so thank you so much for mentioning us. And for anybody who's here, not familiar with us, you can pick up information. We are very action oriented, and collective action is very impactful, and we've got easy things for people to do that take a few minutes a month, or you could spend a lot more time doing things with us, but we welcome it all. I'm wondering about, do you see growing movement among meteorologists, like to talk about this more on, in weather forecasts locally, because they tend to be kind of trusted, I think, and trusted messengers are really important. So anything about that?
Short answer is yes. There is a trend. Unfortunately, as a group, broadcast meteorologists were slow to come around to completely accepting the science as a group, and they were slow to come around to taking the advantage of that they're the trusted scientist in their local communities that people see frequently. They were slow to take advantage of that, and I will say that in some places they still are. But having said that, the trend is very clear that they are talking more about it. They're taking more responsibility for it. A former broadcast meteorologist from Illinois was elected to Congress, and part of the reason he was in order to impact change in climate legislation. And there is a movement that is greater. I used to go to annual meetings of we TV weather geeks, and there would be ferocious arguments sometimes in the 90s. Now there's a lot more talk of how do we work together to make a difference, because there's finally been for a lot of reasons, the last 5 years have seen a significant change. And I say this as somebody who has been watching this for over 35 years. The last 5 years have really changed a lot of things. And you can go into reasons why, probably come up with some of your own theories, but I just want to say it's different. And one of the ways it's different is that it is discussed more on television weathercasts than it used to be. Climate Central, which helped me put together this presentation, is trying to help them with that. And when I work with Climate Central, we're trying to make sure that broadcast meteorologists do more of that. You're absolutely right. It's important. Unfortunately, we squandered a couple of decades not doing enough of that. And when I say we, I include myself. I was a broadcast meteorologist from the 80s until 4 years ago. And I talked about it, but I wish I'd talked about it more. And did I ever get pushback? Yes, but management never told me not to do it. They didn't encourage me, but they didn't tell me not to do it. So that's a little personal aspect to that too. Thank you for the question.
I just like to put in a plug for Greta Thunberg's new book. It isn't a book that she wrote entirely. I think she wrote about 20 pages in the preface, and at the end, solutions. In the middle, there's stories or chapters by 102 science savvy climate people. And that is what we all need to study. I was reading my copy last night, spent half the time writing notes.
Yeah.
Thank you.
Thank you for making that plug. I have not yet had a chance to read her book, but I've heard good things. I look forward to reading it myself. Just very briefly on books, I bring only 4 with me. There is literally, there can be a wall in bookstores of climate change books. And so I'm not saying that these are the only books, but these are books which I have found to be important. Saving Us by Katharine Hayhoe is especially about how to talk to people. Number one, how to talk to people, because I can ask you to do that. I can suggest that you do that. I can say to you, start with something that you have in common and give you tips like that. Katharine devotes an entire book to that. And she is a PhD in climate science, and she is also active in her church. The New Climate War by Michael Mann. He's written several books. This is a superb one, which goes over the political aspects of it and the scientific aspects of it from both a historical and a forward-looking basis. The New Climate War by Michael Mann.
And I will say both of those we do have in the Traverse Area District Library, and they're available if you'd like to check them out this evening before
There
we
you
go.
You go home with-
These other two on his list are on my next order.
Excellent. This is the Carbon Almanac, which just came out. The other two have been out for a year or two. The Carbon Almanac is, as the name implies, it's a reference source, all things related to carbon. The subtitle is It's Not Too Late. The Carbon Almanac, published in 2022. And the last one I have is called One Shade Greener at Home. This is specifically designed for changes in your home that an individual can consider. And it's room by room, level by level in terms of if you want to be extremely green or moderately green. Uh-oh, it's the first warning to get ready. One Shade Greener at Home by Lori Sullivan. And thank you, Melissa, for putting those on your next order list. And maybe Greta's book too, if it's not already here. Okay. Yeah.
I think you do.
I believe the second book was The New Climate War by Michael Mann. M-A-N-N, The New Climate War. Subtitle is The Fight to Take Back Our Planet. I've read all of these books and try to get my hands. Your question about, I just read a book about climate science education, and it was very, very interesting. Unfortunately, it's a tough battle. Yes, your question.
I have two children. One's in college and one will be a senior next year. And I noticed massive anxiety in them and their classmates starting late elementary school, especially during middle school. Climate change is an enormous issue for them, and it's speaking to mental health on that front. Can you tell me more about what's being done in schools or these initiatives, and how can we empower our kids?
Well, first and foremost, I think the empowering of our kids is going to have to be done by you and your household. Don't expect the school system to do it. There are going to be exceptions to that, and that's wonderful. But it's primarily going to fall onto you as a parent and your partner. That is important because the school systems have a lot of conflicting interests that are going to make it more difficult for them. But I completely agree with you. There is a massive mismatch between the concern of young people and the people that are making the decisions on what they are taught.
Well, and quite frankly, they're angry at us.
And what wouldn't you be?
Absolutely.
They're being handed a pile. And that's the dirty truth of it. That's what and when you really get into those conversations with young people, it can do as much as anything else to enlighten you as a parent or a grandparent or whatever. And I firmly believe that we should be listening to them, whether it's Greta or any other young person. We should be listening to them because they are not hopeless. They might have climate anxiety, which is very real, but they're not hopeless. Because honestly, they don't have a choice to be hopeless. It's their lives that are laid out in front of them. This is what they're being handed. They understand that in order to make the changes that have to be made, things have to change quickly and big time. Now, some of them are despairing, without a doubt. That they've dug into some things, and there are opinions, even among climate scientists, that there are some climate scientists that firmly believe we've gone too far. But they are in the minority, and there is a whole lot of reason to believe that that is not the case. But back to your question, I think you're going to have to take it into your own hands to educate yourself, to be honest with your children. I'm speaking as a parent of two children in their 20s, to be honest with them about what is and isn't possible, what they can and can't do, and to do the sorts of things, to energize other people, to do the sorts of things that Citizen Climate Lobby do, because that is what is going to make a difference. We are not going to get out of this unless we do. And our generation that's older has every bit as much, if not more, responsibility, clearly, than the children. But I know some people that are my age that are saying, you know, I'm too late in life and it's already messed up, I'm done. I believe with the sentiment, I believe in the sentiment that Martin Luther King said, when you stop being concerned about things that are important, you are dying. And I don't want to be there. And I think a lot of other people can feel that way.
I think climate change lobby representative may say something similar to what I'm going to say, but especially when they're that 20 something or the senior in high school, that's old enough to start get involved in things like climate.
Yeah, I would just like to say that that's one of the things that we do is we try to empower people to exercise their personal and political power, and we work to build the political will for Congress in particular to pass effective policy. We have taken groups of high school students from Traverse City to Washington, D.C. to lobby with us before. We have a group from Kalamazoo going this year. So there are definitely opportunities if they want to get involved in speaking to their members of Congress. We have seen how powerful young people that are as messengers. So I feel for you. I have a 16-year-old, so no.
Yeah, thank you. We can lead, and if we don't want to lead, at least get out of the way because they are energized. At least get out of the way, but I would prefer that we join with them and do the things together. Yes.
So one of the questions that's bothered me for a long time in terms of dealing with things where you need a basic understanding of science is not how lobbying organizations lobby policymakers on, developing laws and regulations and so forth, but how do we teach the policymakers the science that they need to know in order to make wise decisions about what they do?
I think I said at the beginning that you ask questions and I try to have the answers. I don't have that one. I wish I did. As I say, I briefly mentioned the former broadcast meteorologist who was elected to Congress in 2022. And he's been very explicit that one of the main reasons he wanted to do that was so that he could talk to the other people in Congress and help them understand and knock their heads together if necessary. But he has a level of credibility as a scientist, an atmospheric scientist in this case, that perhaps no one else does. So when I go back to number 10 and say to vote with climate in mind, if we put more people that are scientists into the positions of power, either on the national or the state level or even the local level, that'll help because they can help educate them because maybe those people weren't educated properly about science in school or didn't go to a presentation like this. So we need to do everything we can to try to get those people either educated or replace them with people that are. That's the closest I can come to an answer. Yes, that's what I'm doing in Detroit. Yes. Thank you. That's what I'm doing in Detroit. Because I have found an enormous lack of fluidity in the science. Yes. And understanding in the science. And I am trying to do that, but obviously I'm one person. But I am navigating the labyrinth of Detroit local government in order to try to do that. But I sometimes feel like I'm beating my head against a wall, but I'm going to keep trying. And other people are trying to do the same thing because learning and education and information is the key to the rest of the change. And that's why talking to people about climate change is number one. But what everybody here can do the same sorts of things with communication because I may be trying to talk to the policymakers in Detroit, but I may not even be their constituent. But if you're talking to your representatives, you have more potential power than I do.
Last question.
Kind of a comment. Well, I have a comment and a question, but comment is, sounds like we all need to be writing Gretchen Whitmer right now about making Michigan a state that does include climate change science in our curriculums, because you mentioned earlier that Michigan is not one of those states, correct?
That's correct. Although with the makeup of the legislature and the governor's house right now, we might be at an opportune time to work something like that through. You are right. Yeah.
Right. And I guess my question is kind of about what's your sense of nationally and globally? Like, I know 10 years ago, there was still so much conflict about, whether this is global warming, climate change was a real thing. And I mean, even though, of course, we all believed it was, but many people were still arguing about it. How much has that changed, do you feel like, with leaders and legislators and
Okay, great question. First of all, even if you go back 10 years, the primary places where there was still debate about this were the United States of America and Australia, and to a smaller degree, Canada. Most of the rest of the developed world was way past that. So when you talk about, oh, we've made some change in 10 years, in this country, we sort of have, but we're still playing catch up to most of the rest of the world, which has not even considered whether it's a debate anymore for more than 10 years. And they're moving past it in terms of policy changes and things like that. That's part of the reason electric heat pumps are so widely adopted in Western Europe, because they got past that part a long time ago in Western Europe, and they're working on the solutions. So it is primarily us, and to a lesser degree, a couple of other countries with a long history of fossil fuel dependence, Australia and Canada in particular, where that has changed in the last 10 years. So we're sort of playing catch up. We still have work to do in this country, without a doubt we do. But when people say, well, we can do all these crazy, wonderful things in this country, but what about China and what about India? Places like that actually look to us for inspiration, for information, for funding in some cases. For instance, with India is still more than 50% coal-fired, and their population is growing immensely quickly. They need help from countries like ours. We need to shore up our own political will, and then help other parts of the world as well. Because if nothing else is clear, I hope it's clear that the obstacles that we have, they're not physical and they're not technical, they are indeed political. And that's exactly what your question goes to. And I recognize that we're out of time, and I don't want to be physically thrown out. But I do want to thank you all for being here. Again, weatherchris.com is a place you can reach out to me if you have further questions. If you know a group that might be interested in a presentation like this, please reach out to me. Thank you all for being here. Thank you for your great questions. And I wish you luck in doing what we all need to work on together. Thank you.